The last video explored a method for approximating pi by finding the probability of a random event occurring by throwing objects. Well, this method is no different. However, instead of using dice, we're using needles. This method is notable with a French naturalist whose name was, and bear with me here, Georges-Louis Leclerc, Comte de Buffon. Apologies for that probable awful pronunciation, but this is why this approach is dubbed Buffon's needle. This method involves dropping a thin needle, or anything of similar shape like a pencil, onto a lined surface, where the lines are parallel and equally spaced. It is possible to determine the probability that a needle crosses a line, and this result is directly related to pi. This arises from some calculus and manipulation of a probability problem, but to do this yourself, none of this is necessarily needed. Either way, this relation differs depending on the size of the needle in relation to the distance between each line. For simplicity, the experiment I will explain will consider only the case where the needle-like object and the distance between the lines are the exact same, given this is the simplest in terms of mathematical operation. Find a surface with parallel equidistant lines or draw them yourself. This is an experiment that I did, where I made my extremely makeshift setup with definitely not straight rope and cans of drinks. For simplicity, just throw pencils or pens that are the same length of the distance between these lines and count the number of times a needle crosses a line. Now everything is in place to estimate pi. The probability that a needle crosses a line can roughly be found by taking the number of times a needle crosses a line and dividing by the total number of needles thrown. But pi can be approximated by finding 1 over the probability that a needle crosses a line. And so in other words, pi is approximately the total number of throws divided by the number of needles that cross a line. Remember though that this relation will only hold true for when the length of the needle-like objects is the same as the distance between the parallel lines. If the needle-like objects does not satisfy this condition, then other equations have to be used to approximate pi. Again, this is a weird place for pi to show up, and this method is thought to be the first that solves a geometrical probability problem. That's all from this video though, and I'll see you in the next one, which will be the final installment of A Quest for Pi.